Now, let's go a little deeper. Now, let's talk about a framework called LangChain. And I think the reason I'm bringing LangChain here is that LangChain is a framework which binds every aspects of an AI application, every aspect or every tool chain that you need to build an AI application into a single framework. And we're going to look at how does it work. But there is also something called prompt template that is provided by LangChain. But before that, let's try to understand what is LangChain. So LangChain is kind of an orchestration layer. It's an open source framework for building AI applications. So if you look at this way, right? So you have row API complexity. You can see it in this way, that when you are inside a room and you are actually trying to turn down or control the AC, right? When you make it from 26 degrees to 22 degrees, there are certain things happening with the AC through some sensors, right? The data that is emitted by the sensors to determine what is the current room temperature and etc. are a very complex set of data. But as a user, when you are trying to actually interact with those sensors, all you have is a knob. And you can think LangChain as such framework, which kind of takes away this raw API complexity to kind of create a better way for you to basically consume all those things into a single bucket, right? So there are 4 main building blocks of LangChain. The first one is the prompts or the prompts template. So it's the templates that manage user input and insert users variables dynamically. Because when you are actually creating an AI system, you are not hard coding the context all the time. To give an example, let's say you have created a system where it is actually telling you an employee's summary, his or her performance. Now, to basically make LLM analyze that employee's performance, you have to fetch information dynamically based on which employee user is asking through some APIs, right? So that context becomes a variable for that system prompt that you have created. So this provides great prompt templates. Then there are LLMs. Now, this framework, basically a standard interface for all models. It can be models hosted by OpenAI or Gemini, or models which are open source like Llama 2, Llama 3, which you have hosted yourself. It's a single one interface which makes a swarm of LLMs available to you, which you can access through some classes and APIs. Then of course it says, the name says LangChain. So there are chains which are basically sequences where output of one step can be an input to the second step. And they have this framework has an amazing way of basically creation of those chains together, right? So you can, for example, there are SQL chains, there are other chains available for you, readily available, which you can just call and use in your application that you're building if your use case requires this type of step-by-step implementation. And then there is the fourth part is indexes, which is basically data ingestion tools. It gives you a lot of data ingestion tools like document loaders, and this document loaders can be from multiple third-party sources as well. It can be an Airtable, it can be your Mongo, it can be your AWS S3s, etc. It also has vector DBs connection, which are slightly different from this relational ones that you have, but they also have provisions for integrating with a lot of external and open source vector DBs. So these 4 things basically creates the building blocks for LangChain's framework, right? And now if we look at that, how it the runnable protocol, which is basically one of the primary protocols of LangChain, kind of binds all these things together and runs this as a chain. So it's basically one combination of one or two of the four that we discussed, or all four together, it tries to retrieve the context from multiple sources. For example, it may use the document loaders to basically fetch some documents and then summarize and give you the answers looking at the prompt. So basically there is a magic, or there is amount of engineering happening behind the scenes of this retrieve and summary, but LangChain is kind of binding all these things together. And what it is doing, right? Adding context and agency. Now, LLMs are stateless. LLM doesn't have any questions. So let's say, what I mean is that, let's say you quickly build a chatbot with LLMs, and you ask it a question like, hey, I'm JD and I want to know what is 1 + 1. It will say, hi JD, 1 + 1 = 2. Then if you go back and you ask it what is my name, by default it will not have any kind of memory, and it will say that, hey, you have not told me your name, do you want me to tell your name, or something like that. Now through various tools, what LangChain does is gives this long-term memory to any system that you're creating, which is very, very important for most of the AI applications that you are trying to create. The second thing is agents using LLMs as a reasoning engine. So yes, we do have large reasoning models now, which kind of does these things right now, but large reasoning models are costly as well. So if you want to build or orchestrate yourself, LangChain framework also provides you that agency or agentic orchestration. But having said that, there are other tools also available for you if you are purely building an agentic solutions like Crew AI or Autogen or LangGraph, etc. But just wanted to bring this up as well here, is that there is also a tool agent orchestration that you can do, where you can assign a specific set of tools to a specific set of LLMs, and when they can use it to do certain tasks. So if I try to put this into a fully automated picture out here, when the input comes, right, the prompt templates kind of makes sure, and this is in context with the previous the first application of bug reporting that I started with. So the prompt template, if I have created a prompt template using LangChain, it kind of makes sure that before it goes to the model, the instruction sets are very, very clear and concise in nature. Now model kind of understands this prompt template and creates a valid JSON. At least the model believes that it has created a valid JSON, but then there is a loop that I can have which can retry or repair through the runnable that I was talking about, to make sure that the JSON that comes is exactly what we needed from the prompt template that we have provided. And once it becomes valid, and then it goes to the application which I'm actually building, which is the front end part of it, right? So and this validation is very, very important, right? And this is one of the primary things why I brought LangChain. There are other frameworks also available which kind of provides these type of things, but I started to use LangChain, I think, the day it came, so I still use it in many cases, so I thought I'll bring it up. But this flow, I hope it makes it clear that where does everything fits, and how important is this to have a framework like LangChain when you try to build an AI application yourself. So some real world use cases are basically creation of chatbots, where you want to create context-aware communication, and maybe it's a standalone chatbot, it can be a Slack or Teams integration. Summarizations, where you want to get or receive the transcripts or emails from many sources and try to summarize them in a specific way. Data augmentation, where you want to have generating synthetic training data, or you want to create virtual agents who are autonomous task execution like an RPA. So these are some of the cases where I have built applications, some using LangChain, but some using some of the other frameworks that we actually have. But that's it for the video. But before I wrap up, I want to reiterate the 3 steps, and then I'll just go ahead and end it. The 3 steps. What are these 3 steps to basically create an end-to-end application? Step 1, the prompt template. Your role, you are a triage assistant, output is JSON. And again, I'm talking from the perspective of the initial use case that I had. And these prompts become reusable. So the user bug text that you see is basically coming dynamically when the application is running. Step 2 is the model call. This formatted prompt goes to the model, and the model kind of gives a candidate string with the stuff that was asked in the prompt. It looks like JSON, but it's just a string. We don't trust it. For example, in this case, what you get to see. So step 3 is the validator or the gatekeeper that you try to bring, which kind of goes through the output that is given by LLM, tries to understand whatever was asked in the prompt, is it present or not. If not, it tries a loop and gives back to the LLM with some modification or what is needed, and then at the end it basically gives the valid output, and this goes to the application that we are trying to make. So with this, I hope you got a quick understanding of LangChain and how LangChain plays in the role of prompt engineering. I hope you also got a differentiation between prompting and prompt engineering, which are two different things. But maybe if you have not built any web application, AI application yet, it's time for you to use something like a LangChain. It's very quick to start, and it also you can use in Python. Python is one of the languages that probably you can get started pretty quickly to build your first chatbot. And one of the best way to learn is basically try it out. So just try these things out, and I think you will get a better understanding of how do you use some of these tools provided by these frameworks. Thank you so much for your time, and I'll see you in the next video.